All right, let's look at some radical equations where the variable shows up more than once and see what kind of mess that makes for us. So one of the things that we really want to focus on when we're solving these is that you need to isolate the radical before you square to get rid of it. Otherwise, it might not successfully get rid of it. This is interesting because I do have t on both sides, but I also already have one of the radicals isolated. The other one I would say is not isolated because it has the 2 out in front, but if I get rid of that 2, I would do it by dividing both sides, which would isolate the square root of t minus 16, but then the square root of t minus 4 would be divided by 2 and it would not be isolated. So I actually don't think I can do any better than this with my isolating. I'm going to go ahead and go straight to squaring both sides. Again, when you square both sides, remember it is what I said. You are squaring both sides. You're not squaring part of one side and part of the other side. You have to square everything. So parentheses and a square, and then deal carefully with what that means. On the left-hand side of this equation, what that means is exactly what we would hope. It means that we take t, we subtract 4, we square root, we square. Those two operations will cancel. They're happening back to back, they'll cancel. On the right-hand side, there is a step in between. We would take t minus 16, we would take the square root, we would multiply by 2, and then we would square. So we have to be very careful with this. But remember that squaring literally means multiply it by itself. And if we think carefully about that, that means we're going to get a 2 times 2 that we can kind of regroup together and say that's a 4. And then we get a root t minus 16 times a root t minus 16. When you multiply a root by itself, that is squaring. So that does eliminate the square root. So I'll just get a t minus 16. Those parentheses are really important. Square roots are grouping symbols. They're like their own parentheses. It groups the t and the 16 together. Even if we get rid of the square root, we can't get rid of the fact that they were grouped without thinking carefully about it. In this case, if we drop the parentheses, we might miss the fact that the 16 needs to be multiplied by 4 as well. So t minus 4 equals 4t minus 64. Interesting. Okay. And now we have turned that radical equation into a linear equation. So I still have t's on both sides of the equation, but I know how to deal with that for a linear equation. And this will be our strategy kind of from here on out through algebra and pre-calc and so on. When you're trying to solve, you're always trying to get back to a linear or a quadratic equation if possible. We have great strategies for those. So that's why we spent hopefully a good amount of time at the beginning, enough to make you pretty comfortable with those methods. I will focus next on getting my t's on the same side. So I'll subtract t from both sides. And I will say negative 4 equals 3t minus 64. Now I'm going to work on getting rid of everything that's with the t. So I'll add the 64 to both sides. If you're comfortable, you could do those last two steps together. Here, negative 4 plus 64 will give me 60. And on the right-hand side, I'm left with 3t. So I need to divide both sides by 3. 60 divided by 3 is 20. So I get 20 equals t. This is a radical equation. So this is just something you will have to train yourself to remember. You always check solutions to radical equations. In this case, if I check, I get the square root of the square root of 20 minus 4, so the square root of 16 equals 2 times the square root of 20 minus 16, which is 4. The square, and this is a question mark, the square root of 16 is 4, the square root of 4 is 2, so we're asking, does 4 equal 2 times 2? And the answer is yes. So this is a good solution, we'll keep it. T equals 20 is the answer this time. Okay. One more in this video. Let's see, let's try dark blue. The square root of 3n plus 1 equals n. So again, we have n's on both sides of the equation, and I don't love that. But in order to be able to move the n's to one side and actually combine them, I have to free the n's from under the square root. So even before, remember, even before you start trying to get n's on one side, you first want to clear out any mess from the equation. So that's going to be our strategy. Big strategy. Step number 1, clear mess. And by mess, I mean anything your variable is stuck in. Parentheses, square roots, fractions, which we'll work on next, anything like that you want to try and clear so that you can move your variables around as needed. 2, get your variables all on one side. And then from there, we're going to go to our usual strategies. Either it's linear or it's quadratic at that point. So whatever you would normally do for that kind of equation, go for it. Okay, so clear mess is our step number 1 here, which means clear the square root. And before you clear the square root, you need to isolate it. So my first step, and this is really important, this is the most common thing I see that gets people in big trouble, maybe second most common. I think I gave you a most common earlier, but it's a very common thing I see, is trying to go ahead and just square here and saying, okay, the square root of 3n plus 1 squared is 3n plus 1, and 1 squared is 1, and they just drop that root, but that's not what it means to square that. If you wanted to square the square root of 3n plus 1 plus 1, that's a ridiculous one for me to say, you'd have to multiply it by itself, and when you FOILed that out, you would get rid of the square root in one of your products, but not in 2 of the others. It would be a mess. So once I've done this, it is reasonable to say, okay, now I can eliminate the square root by squaring both sides, and I really do at this point get 3n plus 1. On the other side, n minus 1 squared, remember that's n minus 1 times n minus 1. So this is number 2 really common error, is people maybe remember to isolate the root, but then they forget to FOIL out n minus 1 times n minus 1, and I'll just see n squared plus 1 or n squared minus 1 here. The truth is I should get an n squared, I should then get an outside of negative 1n and an inside of negative 1n, and then my last 2 should be a plus 1. Okay, so this is quadratic. For quadratics, I either want to use square roots if there's only a single n floating around. That's not true in this case. I could also set equal to 0 and factor, or set equal to 0 and use the quadratic formula. Or if you're feeling pretty sharp with complete the square, you can always use complete the square, and then square roots would work. Let's go ahead and set it equal to 0 and regroup a little bit to see what we're actually working with. So I'm going to subtract the 3n and the 1, minus 3n minus 1. And I end up with 0 on the left, the n squared. On the right, I have negative n minus 3n. That gives me negative 5n's. And then I get the plus 1, but I also have a minus 1, so that actually drops out completely, which is kind of nice. So I just end up with this 0 equals n squared minus 5n. This should be your favorite, but the truth is I know that because it looks a little different, this one actually throws a lot of students off. Don't forget, if you're trying to check for factoring, that the first thing you should check is a greatest common factor, and that does happen here. I have a common factor of n. If I take that out, I end up with just n minus 5. Remember, factoring it out is a division, so you're really dividing n squared by n and dividing 5n by n. But that can be a little tricky to think about, so if in doubt at all, just remember you can distribute it back in to check yourself and make sure you really will get n squared minus 5n when you do that. This is a factored form, so now I can say either n equals 0 or n minus 5 equals 0, which means n equals 5. We have to check both solutions. This is very important. When I check, always check all the way back up in the original equation. Any of those steps you do along the way might have introduced new solutions. The truth is here, the only step that we did that could introduce new solutions is squaring, but you always want to go back to the original just to be safe. So I get, plugging 0 in for n, the square root of 1 plus 1 equals 0, and that is not a true statement. Notice, however, if I was allowed to put a negative sign in front of that square root, it would be true. The reason I'm pointing this out is because it can be hard to tell when you're checking solutions whether they don't check because you've got an extraneous solution or they don't check because you made a mistake. And the extraneous solutions always happen because of a plus minus problem. So if you just think about what if I change the sign in front of the square root, if that would have made it true, that's a really good sign that you found an extraneous solution as opposed to having made an error along the way. So we're going to cross out n equals 0. So this is not true. 1 plus 1 is 2. 1 plus 1 is not 0. For the n equals 5, my check is 3 times 5 is 15, plus 1 is 16. So I get the square root of 16 plus 1, and I want to know if that equals 5. And that is true. 4 plus 1 does equal 5, no sign problems. So my one and only solution is n equals 5. So as you work through these, you should either at the end have one solution or two solutions. Once you get to that point, you need to check. And you might end up throwing away all the solutions you have, in which case you would say no solutions. You might end up, if you have two, only throwing away one of them, in which case you just list that one that was left. You might end up with two solutions and they both work. So there's not a rule here. Don't try and predict, okay, if I get two solutions, I should throw one away. That's not a rule. You might throw away both, you might throw away one. So just check them thoroughly and you should be able to tell what's a good solution and what's not. Thanks for watching.